Bonjour, hello, and welcome to today's webinar brought to you by Solid Experts. Today we'll be talking about GeoMagic Design X, reverse engineering from scan-to-CAD. First, let me introduce myself here. I am Richard Forcier. I've been working as a manufacturing engineer for about 10 years now before I came over here to Solid Experts, all the way from aerospace to thermoplastics to laser cavities. And throughout that process, I got my bachelor's in mechanical engineering. So, first of all, let's get into what we will be talking about today. Our first bit about it will be, what is DesignX? The second bit about it would be kind of the overall process of scanning and then getting through DesignX, how we like to use it and how we do use it, and how the industry uses it. And then we'll close out at the end with a little bit of Q&A with anyone on the webinar. So first things first, what is DesignX? DesignX is a professional-grade reverse engineering software that transforms 3D scans such as mesh files, point cloud systems into parametric CAD models based off of your design. So right here on this slide, we're going to use this bracket. On the left side, we have our Artec Studio little scan file. Then we have our post-process DesignX final form. So this is what we are shooting for out of DesignX. And then in the last one here on the right, this is what the part looks like when we export it into SolidWorks. So let's get down into the process of scanning and using DesignX. So first things first, you need to have a part. If you are using a scanner, you are probably trying to figure out what this part shape is. Although in DesignX, you don't technically need to have mesh data to do any of the CAD work. DesignX is a full CAD software in its own sense. However, that is not the original intent. The original intent is for reverse engineering based off of those point clouds and mesh data. What I'd like to show here real quick is just to reiterate kind of what we're talking about, in that there is no data found in this file, and I am still able to just use all of your standard SolidWorks designing tools or Fusion tools, whatever software you're used to. And you can CAD out a simple geometry block, or if you really want to, you can go into super complex parts, and you can take this and export it as a step, whatever you need to do to get into your next operation of either a 3D printing or using that as your CAD solid. So in this instance, it's just a little dumb block with some holes cut into it, and we're going to add some radiuses to the end of it. But throughout this whole process, there was no mesh data used throughout the entire operation. This is just simple CAD tools found in DesignX. Moving on to the next slide here, we're going to talk about the step 2 of the process. Step 2 of the process for us is because we are partnered with Artec Studio and we have almost all of their scanners. We opted to use the Spider 2 scanner to collect the data on this bracket. So as you can see here, we captured probably close to 99% of this bracket, but we don't need to focus heavily on collecting every bit of data. Because in DesignX, it is not required to have a watertight mesh to operate in. You can have a very large amount of data missing from your file, and you can still use it for your overall reverse engineering process. This part here, we cared primarily about the overall shape, the hole locations in that little triangle pyramid found in the middle. So this is what the part looks like inside of Artec Studio. You can kind of see how we're talking about in those through holes up here, that there's a lot of bubbling and kind of weird geometry going on in there. Now that can be found either in part defects or through the scanning. It's hard and just in general difficult to get through holes with the scanner. I could take a lot of time here and try to go back in with the scanner and collect lots and lots of data and make these nice and smooth. That is not needed. We can take this as it is, import into DesignX, and use this to start doing our reverse engineering, which that's what we are going to do. So this video right here, I'm going to go ahead and start, is a sped up version of what we would generally do in DesignX. So as you can see here, we are using the mesh sketch feature to get our overall dimensions found on the part. If it wasn't possible to get the CAD file from any of the other engineers or whatever reason on this 3D printed part, this is how we would generally go about collecting that data. As you can see here, I'm not specifically using those pink mesh sketches as my overall dimensions. I'm using them as references, and then I'm dimensioning my sketch around them to get my real world practice. Because I want this part to have overall controlled dimensions, such as, for me, I like whole numbers or half numbers like 40.5 or 40 or 41. I'm not looking to have that 43.3333 millimeter part. That is not the intended use for this piece of bracket here. That is just a defect coming out of printing, warping, scanning, whatever the tolerances are on your scanner and whatever the tolerances on your printer are, and then whatever the real world use is here. I'm not sure if this bracket was ever installed on something, which again, if you are printing something or you're machining something, you go to use it, you might want to measure it later to figure out your defects that you have going on here. Or you might break it and you are trying to figure out how you broke it. Personally, like I said, I try to not rely on those. I will use the pink sketches for any of the abstract splines that are just really not a uniform radii or anything like that. I prefer to use conformed numbers like radiuses that are all pre-built standard numbers. It makes it a lot easier later when another engineer is looking at it and they're not trying to do any funky math, or they're not breaking their part trying to deal with your weird dimensioning that you have going on here. This bracket, as you can see, it kind of has some relatively loose tolerances. That's because it wasn't printed at an extremely high resolution, and we are not required to have this at an extremely high tolerance. We are going to be using our 100 micron little tolerance here. You can see on the right side screen as I keep turning on and off that deviation to make sure that I'm not deviating too far from my CAD bodies from what the mesh data is. Now, there's always going to be some level of deviation in your physical CAD model to the actual mesh data. That's because your CAD is your intended perfect world part. Now, as we're all familiar with, it's almost impossible to get a intended perfect world part. And that is what you're seeing here. As I keep turning on and off that little data, that little analyzer tool there for the deviation, you can see that I'm changing maybe our radii to be a little bit smaller, a little bit bigger to conform to what the mesh data is, but I'm not trying to get it down to the 1 micron accuracy on this one. I'm still relying on those whole numbers of like 8 millimeters or 8.5 or anything like that. I'm also doing the same thing as I am sketching out these holes. You can see me putting them in a rough location, starting to lock them in permanently with my dimensions, and then altering those dimensions as I feel they visually fit better and fit into the more conformed part that I am trying to produce here. So as this video here kind of runs out to the end, I would like to explain that we are using kind of like the general features found in the DesignX Pro software on this one. We're not going to dive into any of the super complex things here for this little bracket. We're just going to use what I found to be just simple little tools to get our start to finish part here. So I'll go ahead and show you the end all deviation here on this part, and I'll back it up just a scooch so you can see it. This is heavily deviating on the top because I haven't put in those radii. Once those radii are fully confirmed in there, and we'll move on to our next slide so you can see that. This is our overall finished part of the DesignX design here. As you can see, there are deviations found all throughout the part. On this part, we ultimately found out that this bottom part of the bracket here was warping up. A common factor of 3D printing, that like if it doesn't heat right, doesn't cool right, you'll get warpage. During that, we again don't specifically care on this one because we now have our finished part that has all of our whole numbers, and it can be reprinted, and we can try to get a more tighter tolerance part, changing our print settings, whatever. Or again, we don't know if it was installed on a part, which probably caused most of the warpage if that was there on this. But the best part about DesignX, in my opinion, is when you're working in a large industry like this, where lots of different CAD softwares come in, everything that you do in DesignX will transfer over. So this is our drop-down tree from DesignX on the left side here, and everything that was done in that operation transferred over into SOLIDWORKS. So now whoever is in SOLIDWORKS can see exactly how you did it. This is very important for your engineering and design team because they can see exactly how you did it. They can also judge you heavily based off of how you did it. That'll leave that for you guys to decide which way you found best to reverse engineer this bracket in the comment section. There's already been a couple ways of how we did it here. It's very important to the engineering team to be able to see kind of how you designed your part when you were reverse engineering it, because they're not going to ultimately see the mesh data, especially if you're working internationally or whatever, where one side has the part, one side doesn't have the part, and you are doing just long distance calls back and forth, whatever. That's always just a nightmare to deal with. So having that ability to have that tree transfer over kind of removes that middle part there of like, hey, why is this dimension like this? Why is this radius like this? Oh, he put in this dimension is 45 flat. it's not 43.333, whatever. And because in the deviation analysis there, you can also shoot that over to them and show them exactly why you did that. It is, again, user case dependent on how you would want to use that data. How we like to use it and how the industry likes to use it is still the same overlap. We generally use DesignX to help a lot of our customers do reverse engineering. We might not necessarily do the full design through it, but we will get you your part as a whole number basis, or we can get you into an extremely high level documented, forced FAI controlled, whatever you need. We can do all that here. What I found heavily is that we've done a lot of sand-casted parts or just casted parts in general, because there's one of the oldest forms of manufacturing that we've found to date. A lot of these parts can be hand done or hand ground or altered over lots and lots of time. And through DesignX, it allows us to create an accurate CAD model that documents the current state of the part. It also allows us to preserve the geometry of the part and allows a future engineering team to make changes to that part digitally. So as the kind of world changes and we change manufacturing locations, or you want to move to China, you want to move to Poland, you want to be American and bring everything to America, you can do that if you want. That documentation is still there. Sorry, America. In many cases, customers use these new CAD models to manufacture new molds or to continue making the molds that they're already doing, but have documentation control on any of the worn over items that may have happened throughout time. Again, by doing this, we are able to preserve any legacy component and modernize any old style manufacturing. We also use DesignX heavily in automotive racing industries. Solid Experts themselves sponsors several race cars, and we like to win. We are a very competitive time attack team found up in Montreal. We like to have our parts made in-house because we can. So we'll use our scanners to find little air ducts or brake ducts or any component that we found needs to be a different shaped bracket or shave weight, because everyone knows ounces saves time. And we will reverse engineer them heavily through that same process where we scan them, process that data, throw it into DesignX, and reverse engineer it as far as we want in DesignX, then export that into SolidWorks, and then our teams can run full analysis, whatever, so they can bend it 100 different ways to see how strong it is and make changes as needed to get a higher performance part. We find ourselves doing this quite often in the racing world because, well, we want to be first. Lots of common industries use DesignX already. A lot of aerospace and defense companies, automotive, racing teams, manufacturers, medical devices, and a lot of just consumer products. So in the aerospace world, we tend to find it used later after our full assembly is completed. We like to measure out the whole thing, get it into a real world type of part, make sure everything is fitting as it's supposed to be. In the automotive world, it's exactly as we use it. A lot of companies like to scan their parts, make sure that they're not bending or whatever after use, and then we have found a lot of teams will find a way to get into their opponent's garage and measure a part that they don't have themselves, and now you can reverse engineer it and have it on your car. Lots of medical device companies do it too, very specifically. I myself have done the medical device where I scanned a dog that had lost his leg recently, and then we used it to get the mesh data, we put it in the DesignX, and we built a full cast for the dog, and he was able to wear it for a brief period of time. The consumer side of it is exactly as intended. The products that we capture for the consumer side of it is pretty relative to maybe a little bit of the plagiarism guys that want to steal their opponent's ideas. But it is a very well documentation way of collecting that real world data, using it to your benefit and trying to improve your own parts and improve your company's products. Now, why should you use DesignX? There are several reasons why you should use DesignX. It speeds up your time from your reverse engineering very heavily. You technically don't even have to go through the design process on that. When you export your model into DesignX, you can use auto surfacing tools and turn the whole thing into an auto surface. Depending on what your requirements are for your part, you can do that as well. It improves your model accuracy, your precision-based scan geometry. It creates editable CAD surfaces, so that way everyone in the industry can use what you have done. And it is a very good way to rebuild your legacy parts. Now, we like to advertise heavily that it works with SolidWorks and CATIA because, well, we are a SolidWorks and CATIA company ourselves. We use this heavily. That's how we get a lot of our bending simulations done with our race cars. So just a quick recap over most of what we talked about here. The tool itself is a very powerful engineering tool that, frankly, almost all industries use at some level, because they are trying to continuously improve their manufacturing floor or continuously improve their product development. Now, it is a very much industry-leading software. It is owned by Hexagon Metrology now, so there's a lot of high-end Hexagon stuff coming our way. It also helps keep your design intent. It will save you modeling time. And again, I just can't emphasize enough how much it creates CADable features for you. And that is a transversable thing through many different CAD softwares. If you want to learn more about DesignX, please drop a little thumbs up in the chat, and we'll get back to you after the webinar is done. If you would like to keep in touch with me, here is my email contact, my work phone line, and then our overall website. Now, this is Solid Experience, not Solid Experts. Please remember that when you are typing that in there for your email. So let's go ahead and keep in touch. Find us on all of our social medias. We have LinkedIn, Facebook, Instagram, TikTok, YouTube, X now. So if you want to use any of those, please go ahead and scan that QR code. Thank you for joining us for this webinar. I hope it was a relatively intro-level thing here for you guys to get you an understanding of how DesignX is used in the industries and how we like to use it. Please, again, if you want to reach out to us in any way, feel free, or go ahead and move on to those questions, comments, or concerns within the webinar itself. Thank you.